Hi everyone, and welcome to our second video lesson here for circles. We're on 10-2 arcs and angles today. So have your second page of your circle book look just like this. Put circle C, a circle is named by its center, so have the center C right in the middle. Draw a diameter from A to E, and then draw two different radiuses, or radii, from CB and from C to D. So we're titling this lesson 10-2 arcs and angles. And let's first define what a central angle is. A central angle is an angle with a vertex at the center and sides that are radii. So take angle 4 here, for example. Angle 4 is a central angle because its vertex is at the center, point C. And then this side of the angle is a radius, and this side of the angle is a radius. Okay, so we call that a central angle when the sides are radii of the circle and the vertex is at the center. Same thing with angle 1, angle 2, and angle 3 as well. They are all central angles because all of their vertices, or the vertex of each angle is at the center, and all of the sides are a radius. If we add up all the angles, angle 1, angle 2, angle 3, angle 4, we get a full circle of 360 degrees. So if you add up all of the central angles in a circle, you would get 360 degrees. One thing that's also important to note, if angle 4 is, let's say, 40 degrees, then this arc, AB, is also 40 degrees. If angle 2 is 102 degrees, then this arc, DE, is also 102 degrees. Whatever the central angle is, its arc is also the same degree measure. So, now that we have that, let's define what a minor arc is. A minor arc uses two letters to name that minor arc. So here it's named BD. So if I were to name this arc, you can maybe make that nice and dark in your circle book, just like I have it here. This is called arc DB or arc BD. You can name it either way. We always use two endpoints to name a minor arc. A minor arc is always less than 180 degrees. That's why the name minor is there. Minor sometimes means a little bit smaller. So a half circle is 180 degrees. So if it's less than a half circle, as you can see, arc DB is less than a half circle. It's going to be less than 180 degrees. Now it says the measure of arc BD, this is what I'm reading right here, equals the measure of angle BCD. So BCD, that's this angle right here. Let's say angle 1 is 60 degrees. And let's say angle 4 is 40 degrees. Okay, that means arc A to B would be 40 degrees. And that means arc A to D would be 60 degrees. So the measure of arc BD from here all the way to here would be 100 degrees, right? It is the measure of angle BCD, and BCD is also 40 plus 60, 100 degrees. And as you can see, a minor arc, it's going to be less than 180 degrees. In this case, it's 100 degrees, okay? That contrasts with what is called a major arc. A major arc, we name it using three letters. So in this case, arc B, E, D. As long as there is three letters, when we label an arc, that's going to be greater than 180 degrees. Okay? Right here. It says it's always greater than 180 degrees. So please write that down in your circle book. We can find a major arc just the same way we did on the other, on a minor arc when we added up angle 1 plus angle 4. You could add up this angle plus this angle. Or if we wanted to, we could take 360 degrees minus the minor arc. Remember how arc BD was 100 degrees? Well, that means that this arc right here has to be 260 degrees. Because 360 minus the minor arc of 100 gets us the major arc of 260. So the formula 360 minus the minor arc, which is 100, gives us 260 degrees. Okay? So a minor arc is always greater than 180 degrees. Sorry, I maybe said that wrong. A minor arc is less than 180. A major arc is greater than 180. And a semicircle is exactly 180 degrees. We also label a semicircle with 3 letters, so 3 points. Point A on the circle, point B on the circle, and point E on the circle. This would be a half circle, and a half circle is 180 degrees, or a semicircle. You can see here that AE is a diameter. That segment is a diameter. So it cuts the circle in half, and half of a circle is then this 360 degrees. All right, and then the last thing that you're going to put on your circle book here is if we want to find the measure of an arc, this arc length right here, or if we want to find the radius of a circle or a diameter of the circle or the circumference of a circle or something like that, we're going to use this formula. It's a proportion, the degree of the arc that we're talking about, divided by 360 degrees. That equals the arc length of the part that we're talking about, divided by the circumference. So we're going to be solving some problems using that formula today. All right, you can put away your circle book and now take out your notes packet. And in your notes packet, we're going to solve a few of these arcs or angles. So it says find the measure of angle AVW. AVW is this right here. Okay, well, the way we do that is we solve for x, and once we solve for x, we multiply it by 25, and we got our answer. So how do we solve for x? AQ. This would be a diameter, wouldn't it? It's a chord that goes right through the center of the circle. So that means that this is a semicircle, which equals 180 degrees. So 25x and 3x and 2x, when we add them together, it equals 180 degrees. And that's how we're going to solve. 25x plus 3x plus 2x equals 180 degrees. It equals a semicircle. So 25 plus 3 plus 2 is 30x. That equals 180. Divide both sides by 30, and x equals 6. So if x equals 6, AVW 25 times 6, 25 times 6 is 150 degrees. 150 degrees, yes. So angle AVW equals 150 degrees. And so then also its arc, AW, is also 150 degrees. The measure of WR, or this angle right here, is 3 times 6. 3 times 6 is 18 degrees. 2 times 6 is 12 degrees. If we add up 150 plus 18 plus 12, there we have it. We have 180 degrees. So our answer on this one is 150. Taking a look at this next one, find the measure of angle AVZ. AVZ is this angle right here, which is also this arc. They're the same. We're not really given any information about it. However, we concluded that this angle was 150 degrees. We concluded that this angle is 18 degrees. And this angle is 12 degrees. And isn't this angle vertical to this angle? Right? Or isn't this arc vertical to this arc? So they would be congruent. So this one also has to be 150 degrees. So that means that this would be a diameter. And in a diameter, this would be a semicircle of 180 degrees. So this one has to be 30 degrees. Because 30 plus 150 makes our 180 degrees. So angle AVZ equals 30 degrees. You also could have taken 108 or 360 minus this, minus this, minus this, minus this to get us the last angle of our circle. 30 degrees is our answer for this one. Why don't you guys pause the video and try these next two on your own, please. After you try this on your own, you should have gotten x to equal 7. And so then you should have gotten angle RTS, to equal 52 degrees. Let me know if you have questions on that when you get to class tomorrow. On this one, again, x was 7, so you should have gotten angle QTR to equal 40 degrees. That's what you should have got for that one. All right. On this one, it says PL bisects angle KPM. So if PL bisects KPM, this angle would be then congruent to this angle, because PL is a bisector, cuts the angle in half. And then we're given that OP is perpendicular to KN. So this bisects KN. KN is a diameter, so that means that this angle is 90 degrees. All right, well, let's just try to find everything that we know. If this is 46 degrees, this is 90 degrees. This is a diameter, and a diameter makes a half circle. So if this is 46 and this is 90, then this one has to be 44 degrees, because 46 plus 90 plus 44 equals 180 degrees. All right, if this angle is 90 and this is a diameter, then that means that this angle has to be 90, right? Because 90 plus 90 is 180. And so if this is 44, then this angle has to be 46 degrees, because that has to add up to equal 90. Also, it's vertical to this 46-degree angle, and vertical angles are congruent, so that one has to be 46. Okay, so now we're just missing two angles. And so if we take 360 degrees minus these four angles, 360 degrees minus those four angles, we would get, oh, why don't we do that? So minus 90, 46, 46, and 44. If we take 360 degrees minus 90 minus 46 minus 46 and minus 44, there is 134 degrees left in the circle. There's 134 degrees left from here to here. And if these two angles have to be congruent to each other, because PL is a bisector, we could just divide that by 2, and then we get our remaining two angles. So 134 divided by 2 is 67 degrees. So this one has to be 67 degrees, and this one has to be 67 degrees. And so then remember, all of the arcs are congruent to their central angle. So this one's 67 degrees, 67 degrees, 46 degrees, 90 degrees, 44 degrees, and 46 degrees. Whew. All right, we just did the hard part. Now let's do the easy part. Find the measure of arc OK. OK is from here to here. It's 44 plus 46. It is 90 degrees. Find the measure of arc LM. Arc LM is from here to here. We got it. It's 67 degrees. Notice how this is two letters. It's a minor arc. It should be less than 180, and it is. This is two letters, arc LM. It is a minor arc. It should be less than 180, and it is. This is three letters. It's a major arc. It should be more than 180 degrees. The measure of arc JKO. So here is J, K, O. So this huge arc right here. Okay, we could add up 46 plus 67 plus 67 plus 46 plus 90, or we could take 360 minus 44, and then we would get the measure of arc JKO. Arc JKO then would be 316 degrees. All right, the last two of the day have to deal with finding the length of an arc. So if we want to find the length of an arc, we have this proportion where it is the degree divided by 360. That equals the arc length divided by the circumference. Okay, that's our formula. So if we want to find the length of arc MO from here to here, we first need to find out the measure of degrees of that arc. So if this is 90 and this is 46, the degree, the part that goes in the top left part of our formula, 90 plus 46 is 136. So 136 divided by 360, that equals the arc length. That's what we want to find. It says find the length of the arc. So we want to find that. We'll call that our variable x. Divided by the circumference. So what's the circumference of this circle? Well, the circumference of a circle is equal to 2 pi r. And we know what the radius is. It's 8. So divided by 2 pi times 8. That's the circumference of this circle. All right, let's solve for x. We're going to cross multiply, and then we'll end up dividing by 360. So 136 times 2 times pi times 8, and then divided by 360. So we got 136 times 2 times, the pi button is when you go second, and then you have that little caret button right there. The pi symbol is right above that. So 136 times 2 times pi times the radius of 8, and that number divided by 360. The arc length is 18.989. 18.989. X equals 18.989. And that is in inches. And hopefully that kind of makes sense if you kind of look at it. If the radius here is 8, I would say that maybe 8 inches would be like from here to maybe there or so. And then if you did another 8-inch piece, that'd be from like there to there or so. So that's 16 inches. And then we have another 2.5 or almost 3 inches to get to the... Hopefully that makes sense if you think about it conceptually. All right, last one. This one says find the length of the radius if the length of arc JL is 19.01. So again, that same formula where the degree of an arc divided by 360, that equals the arc length divided by the circumference. So this time, we know the length of an arc. So 19.01, we know what that is. The degree, remember, this is kind of the same problem that we had earlier where these were each 67. This one here was 46 and 44 and then 90. So we know the degree of the arc. JL is from here to here. So the degree of the arc is 46 plus 67. 46 plus 67 is 113. So 113 degrees is the measure or the degree of the arc divided by 360. That equals the arc length. We know what that is. It's 19.01 divided by the circumference. And we want to find the radius. So let's say it's divided by 2 pi r, because that's what circumference equals, is 2 pi radius. Now we can solve for r. So if we take 113 times 2 and times pi, we would get 226. 113 times 2 is 226 pi r. That equals 19.01 times 360 gives us 6843. 6843.6 when you cross multiply 360 times 19.01. So now we simply divide by 226 and divide by pi, and then we get r all by itself, or the radius. So divide by 226 and divided by pi. When we do that, the radius of the circle is 9.64 centimeters. 9.64 centimeters. A lot of stuff today. Be sure to let me know if you have any questions or if anything is confusing when you get to school tomorrow.